On with question 3 of your test. This one's about a metal carbonate MCO3 reacting with hydrochloric acid, as shown in this equation. Really, you should recognise here, if you know your ions, carbonate ion is CO3 2-, so you should recognise that the metal is probably going to have a 2+ charge, so it's either going to be group 2 or some sort of transition metal. It gives you some information here. We've got a mass of the metal carbonate reacting with a volume and a concentration of some hydrochloric acid. First of all, calculate the moles of hydrochloric acid reacted, so that's simply concentration times the volume will give you the number of moles. So there's the volume, there's the concentration. Remember again, divide the volume by 1000 to get it in cubic decimeters, and it gives you 0.013 moles. Calculate the moles of the metal carbonate in 0.548 grams. Well, if this reacted completely with it, we're going to look at this mole ratio here, and we can see that there are 2 hydrochloric acids for every 1 metal carbonate. So there's half as many moles of metal carbonate as we had in part 1. So divide your answer by 2 and you get 0.00651 moles. And then calculating the relative formula mass, we're using this equation triangle here in this relationship. Mr equals mass divided by moles. We know the mass, we know the number of moles, plug them in, we get 84.2, and then use part B, use your answer from A part 3 to work out what M is. So you first of all need to take off the carbonate mass from 84.2, which is taking away 60. There's 3 lots of 16 are 48, add the 12 is the 60. Which gets you 24.2. So you look up on your periodic table, look for an element with a mass number around there, a relative atomic mass around there rather, and you find it's magnesium. Question 4, it's all about this reaction here, where we're turning titanium chloride into titanium oxide, and there's a 1-to-1 relationship there. We start off with 165 grams of titanium chloride in water. The amount of moles then, 2 marks for this, for 1 for working out the Mr of titanium chloride is 189.9, and then moles equals mass divided by Mr, which gets us 0.869 moles. So calculate the maximum amount in moles of titanium oxide formed. We've got a 1-to-1 relationship, so it's exactly the same as we worked out in part A. And then calculate the maximum mass we can get. Well, now we're using mass equals the number of moles multiplied by the relative atomic mass. We've given the relative atomic mass here, we know the number of moles here, so we do that and we get 69.4 grams, and then it tells us the actual yield here was 63 grams of the titanium oxide. To calculate percentage yield, you need to recall that it's the actual yield divided by the theoretical yield multiplied by 100. There's the actual yield, there's the theoretical yield, plug the numbers in and you get 90.8%. In question 5, we're looking at this reaction between magnesium and nitric acid. We know a mass of magnesium, we've got a volume and a concentration of nitric acid. It tells us here the acid's in excess, so there's more than enough to react. The first thing we're asked to do is calculate the moles of magnesium in this sample. So it's this time we're using moles equals mass divided by the AR in this case. So we've got 0.0732 divided by the 24.3 of magnesium, which gets us 0.00310 moles. Hence calculate the amount of moles of nitric acid needed to react completely with this sample. So we look at the mole ratio here and we see that for every magnesium there are 2 nitric acids required. So that means we times our answer in part 1 by 2 and get 0.00602 moles. Then we calculate the moles of nitric acid originally added, and this is where we're using the volume and concentration up here, remembering to convert our volume into cubic decimeters. Number of moles equals concentration times volume, and we get 0.00965 moles. So the amount in moles of nitric acid remaining unreacted after all of this has gone on is the difference between these 2 answers here. We know the total amount of nitric acid added was here, this many moles, and the total that had reacted is this many moles. So we do the subtraction and we find what's left over is 0.00363 moles. Then on part B, it talks about an oxide of nitrogen formed in a reaction like this, which contains 30.4% by mass of nitrogen. And we have to try and calculate its empirical formula. Well, we know 30.4% of it is nitrogen, so 69.6 must be oxygen. And then we divide by the relative atomic masses, and we get these answers. We divide by the smallest of those two, we get a nice whole number ratio of 1 to 2. So the empirical formula is NO2. And then the final part of this question is a straight definition. Define relative atomic mass. You must learn this. Relative atomic mass is the average mass of an atom of an element divided by 1/12 the mass of one atom of carbon 12. So 1 mark for the top and 1 mark for the bottom.